3/4 of this, and then the the system failed. We experienced total system failure. So yeah, so we're going to be looking at a lot of the notes from last period, and this is one that's going to go online. So are we ready? Good. I'm glad you're ready. All right. So a lot of the stuff we're going to do, it's kind of loses its magic if you don't see it happen at the moment. We'll just have to deal with it. You know what? Maybe I'm going to do... No, I'm not going to do it. We're going to start here with question 16. And we're finding an area enclosed by... Oh, we did this yesterday, right?
Yeah.
Area enclosed by these two regions. I told you could reflect and use y equals x squared plus 4x and y equals 0. We graphed it. We discovered the region. We did the top curve minus the bottom curve. Integral by hand, antiderivatives, substitution, and my answer was 32/3. Pausing really briefly if there are any questions from yesterday's last problem. Last problem, gave you my heart. Very next day. Yes.
How did we graph the blue line again?
What we use by methods of roots. So if you have y equals x squared plus 4x and you fully factor that, you get x and x plus 4. Give it to someone special. You know that song came out when I was in like elementary school? No, junior high school? Elementary school?
What song is it?
Last Christmas
I've never heard
by Wham.
of it. I'm sure I've never heard of it.
Wham. Oh, no. You know it.
Yeah, you've definitely heard it, Brandon. Isn't that the song they do for the ASL show?
What is Last Christmas
Give it to someone special. Special.
Special.
Yeah. Have you ever tried singing that karaoke? It goes on forever.
I know, right?
It's like after 2 choruses, you're like, I'm done. Don't want to sing the song anymore. There's not even a key change. It's just like over and over again. It's horrible. No, New York has a beginning and ending. That's fine.
That's painful to get.
New York? No.
Well, when I heard it
You're not going karaokeing with the right people. Like I said. 17. Relative extrema of the function. Fx equals 3x cubed minus 5x cubed. The next few questions are kind of a calculus A review, and we did about a chapter and a half of calculus A, really, which is why we were a little bit behind where we should be. First step over here, I'm finding the domain, as was nicely put last period. This is a polynomial function, so the domain should be all real numbers. Have no fault with that argument. Next, we take our derivative. That's the easiest part of this, is finding the derivative. After we found the derivative, I fully factored the derivative in order to find my critical numbers. The all-important critical numbers. You can use that critical number to create this first derivative chart and fill in the first derivative chart. For your reference, I substituted here. I think I substituted negative 10. So if I take a look at my derivative, if I use a negative 10, 15 is positive, so that's always positive. Negative 10 squared is positive. Negative 10 squared minus 1, that's still positive. So I have a positive times positive. So my first derivative is positive. We did something similar here, here, and here. I think I used negative 1/2, positive 1/2, and positive 10. And if you don't remember, the actual value of the derivative is not important. All that's important is positive or negative. Next is the realization that I really don't care about the derivative. What I really care about is the slope. So that's how come I put an m equals here, so I can make that connection between the slope and the derivative. So if the derivative is positive, that means the slope of the function f is also positive, meaning f is increasing. This is a pictogram showing you what the different slopes look like. We can see here, in this picto right here, there should be a maximum when x equals negative 1. And this picto right here, there should be a minimum when x equals positive 1. Okay, next I'm going to substitute negative 1 and 1 just to make sure that existence happens. If f of negative 1 did not exist, then it's no longer a relative minimum. So the function has to have an x-coordinate and a y-coordinate. Since they both have y-coordinates, we can put our summaries here. Relative maximum at negative 1, 2, because the slope goes from positive to negative. Relative minimum at 1, negative 2, because the slope goes from negative to positive. And that's all the relative extrema. Pause a minute here for a minute or so if you need to put some notes. If you have questions, this is a good time for it also. Last Christmas.
Plug it in.
Play Last Christmas.
Christopher, did you plug it back into the original?
Ah, you're horrible. What's that?
Did you plug it back into the original equation?
For which?
To get your relative maximum and minimum?
To,
No,
well,
but it's negative 1, 2, and 1, negative 2. You plugged it into the original.
yeah, y coordinates come from the original. So. Can you sing? Last Christmas.
Oh, you're fine.
Why?
I came for scissors.
You came for sister?
Scissors.
Oh, why not?
Honestly, I maybe I've heard it.
Let's go to YouTube. Maybe there's a YouTube a karaoke version. We can sing together.
Okay.
Yeah, she told me to.
Make this a choir class instead.
Last Christmas.
Your YouTube doesn't work on school.
Wait, there's a Taylor Swift version?
What?
No,
that's a different song. That's a
Kill
different
it with fire.
Is it not the same one?
Is it by Wham? Is it Wham?
Ah, ooh, whoa, whoa. Ah.
You have to put this on the screen, the big screen.
Gave you my heart, but the very next day you gave it away. Gave it away. This year you saved me from tears. I can't believe we're doing this, and we're wasting bandwidth on this too. This is gonna be awesome. Last Christmas. It goes on forever.
Maybe I've heard it.
Huh? I think there's a bridge. Okay, do you know the verse though? Oh, there's not even a verse yet. Okay, that's horrible. Question 18. Back to math. Okay, we have to graph these two. we're told that x is pi, or x is between 0 and pi. So that's really nice. It gives us a place to look for our derivative or our function. Okay, you should be very familiar with graphing y equals 2 sine x. You should know that sine x starts by increasing, and it has zeros at 0, 0, and pi 0. So basically, it just kind of looks like this loop here. Whoops. Okay.
It's like a whale.
Next, sine of 2x over here. If you remember from last year, right around Christmas, when you were graphing trigonometric functions, when you have a 2x here, that just basically means you're going to take the period, and the period's going to be cut in half. So for sine, that means that instead of the period being 0 to 2 pi, the period changes from 0 to pi. So basically, I need to fit the entire sine graph between 0 and pi. Done. Here's the entire sine graph between 0 and pi. We have a 0 right in the middle. We have a relative maximum at the 1/4 and a relative minimum at the 3/4. Yeah.
Will you repeat why you moved it to 0 to pi?
The red curve or the blue curve?
Red curve.
Red curve is a regular sine graph.
Okay. Oh, okay.
Okay. All right. Now that I've done this, notice that nothing weird happens with the area. The red line and the blue line do not cross somewhere in the middle. The red line is always on top of the blue line. So if I want to find the area, I just need to integrate from 0 to pi. Red line minus blue line. Top function minus bottom function. These next few lines show that integration and the area. Let me know if you have any questions there, Brandon.
So even if the graph dips below the x-axis,
As long as you do top curve minus bottom curve.
negatives take care of itself. Okay.
Why is there a 1 being put in? Where did you get 1?
1. I'm not substituting 1. Cosine of pi is -1.
Oh,
Cosine of 2 pi is cosine of 2 times pi, which is 1. Cosine of 0 is 1. Cosine of 2 times 0 is 1. Last Christmas.
Why is it a 2 sine x minus sine of 2x? Why is it in that order?
It's the top curve minus the bottom curve.
2 sine x is... Can I see the graph again?
Yeah, absolutely. This year, save me from cheating. Yeah, it's special. George Michael. Right. Any questions on the integration? Okay, let's move on to the next question, number 19. 19 is a nice and easy question. It's just a derivative. The general power rule. I'm not going to spend a lot of time explaining it. Let me know if you have a question. Maybe I should explain it since this is going on the air. Power rule, bring the power in front before it comes in the front. We decrease the power, that's why you have a 3 here. Then we multiply by the derivative of the inside. The derivative of 3x squared plus 5 is 6x. This is just simplification. Mm-hmm.
Number 18, because it gives you x is greater or equal to 0 and less than or equal to pi, does that automatically mean that 0 to pi is going to be your bound? Are going to be your bound?
It means that 0 and pi are going to play a part in your bounds. Had those functions actually crossed somewhere between 0 and pi, we would have had to do something else. But okay, 19. Let's look at 20. 20 is the same kind of a thing. We're supposed to be taking the derivative. This time we have a product rule, and inside our product rule there's also a quotient, or a, what do you call that? Chain rule. Thank you. The derivative of x squared is 2x. The derivative of the square root of 2x plus 5 is 1/2 2x plus 5 to the negative 1/2
Thank you.
times 2. You're welcome.
Kylie.
So close.
Simplify, of course, we're factoring out the greatest factor, which was x, and 2x plus 5 to the negative 1/2. I was wrong. We're factoring out the greatest factor and the least power. Least power. That's the way you did that in Miss Yu's class, right? Least power?
Yeah.
I've seen people do it differently.
You always said take this.
In Miss Yu we trust. That's kind of like the school's motto. We trust you.
You ruined the balance. The feng shui.
Oh, sorry.
Get it? We trust you. Okay, let's move on to 21, unless there are any questions. 21, this is a nice one. Okay.
Oh, I see it.
Okay. First thing that I would like you to look at is we no longer have y, our x is a function of y. We have the x's and the y's kind of muddled together. Okay, so the easiest thing to do here is to simplify that natural log as much as possible before you take the derivative. So if we simplify that as natural log of x plus the natural log of y, and then now we take the derivative. The derivative will always be easier if you simplify that natural log function first, which is why I recommend you do so. Okay, I put this d dx here to remind you that you're taking the derivative with respect to x, meaning if you have a variable that is not x, you're going to need another derivative, a chain rule derivative. So for example, the derivative of natural log of x is 1 over x, no problem, it's an x. However, the derivative of natural log of y is 1 over y times dy dx. And that dy dx is there because y is not the same thing as x. Same thing here. The derivative of x squared is 2x. The derivative of y is dy dx. The derivative of y is not equal to 1 as long as we're taking the derivative with respect to x. Next step, I took all of the dy's and shoved it on the left side, and everything else I shoved it on the right side. After that, I multiplied everything by xy so I can get rid of all the denominators. Last step, divide and do a little bit of factoring. That's 21. That's the hardest derivative we've done so far today, I think. $22. Oh, can I move on? Okay, 22. This is another one that has a general power rule. So this is 3 plus e to the 3x to the 1/2 power. So just move that 1/2 to the front, decrease the power, multiply by the derivative of the inside, and then simplify. Not a whole lot to this one. I hope you get this one on your final. That's a good one. Because it's easy. I mean, I know if it's on your final or not, obviously.
That's why I was thinking, why didn't you
Gotta look behind the curtain, don't you? Hmm?
Peek.
Don't look at that man behind the curtain. Do you understand that reference?
Yeah, it's
Wizard
from
of Oz.
Wizard of
Okay,
Oz.
good. I'm just making sure. Yeah.
Oh, interesting.
Wizard of Oz is like an old movie, man.
I love that movie.
I watch bad TV shows. That's
Like the Wizard of Oz.
fine.
Like Oz.
I mean,
Did you
Like
see
Oz.
Oz, the
Dog
new
Graham.
Oz Very Powerful?
No.
It was so not.
No.
No, I didn't see that one.
I'm not gonna sully my memory of
Oh.
the Wizard of Oz. Unless it's the Wiz. I like the Wiz. The Wiz is cool.
I've seen
They're
it
like-
parts of it.
And ease on down the road.
The original was also a weird movie.
Have you seen
The
Wicked?
Wiz?
Yeah, what is it?
The Wiz?
Wicked's awesome. Yeah.
Judy Garland.
Yeah.
That's Wizard of Oz.
Of what?
Have you seen Wicked?
No, I'm scheduled to go in January sometime.
Yay. It's awesome.
That's what I hear.
I'm reading the book.
I hear it's different than the book.
It's very different. The book is so dark. The play is not as dark.
I don't like dark. There was this thing in the 90s where everything had to be the dark version of it. It was really annoying after a while. Yeah. We're going to do the Land of the Lost, but it's going to be the dark version of the Land of the Lost.
The Land
Like,
of the
really?
Lost is
Come on. Like, Tim Burton's still stuck there. Alice in Wonderland, but the dark version of Alice.
once visionary direct Batman.
Yeah. But the dark Batman.
Dark
There was
We're going to do the dark side of Superman. There's no dark side to Superman.
Dark shadows, but dark.
Yeah, dark shadows. Even darker.
I get points for that. So good. Oh, and Johnny Depp has to be in every one of them.
Yeah.
Oh, far. Well, yeah, Tim Burton, Johnny Depp. That's a bromance if I ever
It's
saw one.
just what?
Oh, Johnny Depp.
Wait, Johnny Depp? What? That's not what I heard from
Okay, 23 is an area. Find the area. We're going to... No, it's the volume. We're going to revolve this region about the x-axis. I hope you don't have a problem graphing these functions. Y equals root x minus 2. That is half of a parabola with a vertex at 2, 0. First question you have to ask yourself is, do we have a washer or do we have a disk?
Dude.
Okay. I know that disk is circled there, but
Wait, can you remind us how you know if you're
you will know you have a washer disk if there's any space between the region and the axis of rotation. There is no space between this axis of rotation and the region. Actually, that's a really good point. Since the axis of rotation is one of the boundary curves, then we have a disk and not a washer.
If it was y is equal to 1, then we would have a washer.
As a boundary curve, yeah.
And then you just subtract
Mhm.
square root x minus 2 from whatever the other boundary curve was, right?
Yeah. Okay, general formula for the disk method, pi r squared from min to max. Here's my pi r squared. There's the simplification. Gosh, the integration of this is really easy. Substitution, and we're done. You get 8 pi. 8 whole pies. Pi Day's on the same day every year, man. That's one of the properties of pi.
Priority, what are the schools?
You brought in pies last year for Pi Day.
She's a good
Next
person.
year it's gonna be 3.1415.
I'm not nearly as good as she is.
Yeah, next year it's gonna be 3.1415.
Oh, yeah. Next year is an ultimate pi day.
Yeah.
Oh.
Not O, pi. O is not even Greek. Omega. Omicron, thank you.
Omega.
Not omega.
Oh my god.
Omega.
Oh my god.
What just happened here? This, the stupid ray just happened. Any questions on 23? Maybe we should have a pancake breakfast on Pi Day next year.
Yeah.
Why not? Why not?
Why not?
Because they're circular.
That is true. We can cut them.
He wants to chip in for
What day is Pi Day next year?
It's gonna say 3.14.
Checking my sources. It looks like the answer is approximately 3.1415.
Did you say what day is March?
What day is March 14, 2015?
It's Saturday, March 14th.
Oh, no pie for you.
Well, we can have a Friday. Friday.
Why are we gonna get this year already? When did Pi Day?
No pie for you.
Early Pi Day then.
There's no early Pi Day. Pi is about precision.
But we
Oh,
can,
she got it. She got it. She got it.
what about Pi Day Eve?
No.
That's a pie.
3.13 is not a mathematical constant.
Integral.
Okay, 24, we want to solve the initial value problem. This is a bit of a, I don't know, a little deceiving in what you have to do. So let's start off with the fundamental theorem of calculus. If I take the integral from a to x of a derivative, I would get the function, the antiderivative at x minus the antiderivative evaluated at a. Actually, this should be a and b, but I'm going to leave that x there for now. Okay, if I'm told that g prime is this cube root of tangent, and I'm also told that g of 0 is 4, realization number 1, a is 0. Realization number 2, I just need to put this in here for g prime. Alright, so I get the integral from 0 to x of the cube root of tangent x equals g of x minus 4. Remember, 4 is g of 0. Do a little bit of algebra and you're actually done. No one's asking you to integrate the cube root of tangent. It's not one that you can integrate.
This is an initial value because, oh, we're given g of 0. Okay.
And takoyaki would be good today. $25. This is the last one we did. This is the last one we're going to work on. We have this cosine t over 2 minus sine t to the 4th power dt. You're supposed to integrate this. And you know, hey, this isn't that big of a deal. Go down the list of things in order. Number 1, can I simplify this? No. Number 2, oh, sorry, number 1, is this a basic integral? No. Number 2, can I simplify this with trig or with algebra? No. Number 3, can I use a u substitution?
Yeah.
Hey,
yeah.
don't write in my class.
Oh, we out here.
Eddie Lacy.
Yes, we can use a u substitution. U is equal to 2 minus sine t. Did that really just happen? Okay, if u is 2 sine... Really? 2 minus sine t. I bet they don't have to put up with this at Harvard Westlake.
Are you going to Harvard Westlake?
there?
I wouldn't blame you.
Why do they have a Westlake and a Harvard Westlake? Doesn't that make the Westlake kids feel really bad about themselves? Because then everybody's like, where do you go? Westlake? Oh my god, it's so cool. No, not that cool.
Yeah, but
Bella,
Westlake's
we
also
are
in
Westlake.
Studio City.
Sure, we are. Petty.
What?
No, because there's a Westlake and a Harvard Westlake. High school.
Yeah.
Westlake's
Like,
the one
I
with
would
the
feel
really
like
good football
if you went to Westlake, it would be kind of disappointing. Because there's a Harvard
I don't think so.
Then there's Westlake.
Isn't Westlake public?
Is it? No, it's
Oh,
private.
it might be.
Westlake is
public?
I think it is.
Yeah,
Yeah.
but they're probably one of the inner city ones and they get the money.
Westlake?
Oh, they get the money?
Let's move on. U substitution. Hey, we're almost done, everybody. We're almost done. We're almost done. Okay. U equals 2 minus sine t. Du is cosine, negative cosine, multiplied by negative 1, so we have this cosine t is negative du. It's important that you have that because there's no negative here. So this cosine dt turns into negative du, like we see here. The integral of u to the negative 4th power, well, negative 4 plus 1 is negative 3. It's really easy to mess that up and put negative 5. I know right now it sounds kind of ridiculous. Negative 4 plus 1 is clearly negative 3. But, you know, I'm sure negative 5 will be one of the answer choices and it'll look really attractive to you tomorrow or on your final. Anyways, here's our antiderivative and we are done. Oh my gosh, what did I do? Okay, any question? No.
Can we cater donuts in the final?
You can bring donuts if you want.
Like, this is my last final. Like,
Yeah, because it's experience.
well, actually, this is all of our last final.
Have you figured out when I
Maybe we should do a little party.
How are we doing on